Good morning. We are PCM 2023. I'm at the onsemi stand. I'm with James Victory, Fellow of Modeling and Simulator at onsemi. Good morning, James.
Good morning, Ricardo.
So, PLECS model simulation, this is very important. What is about?
Yeah. So PLECS is a system level simulator. It's a level up from SPICE. A lot of people are familiar with SPICE, where you can simulate transients and do overshoots and ringing and things like that. Problem with SPICE is it takes a very long time to get to steady state.
Yeah.
PLECS lets you simulate at a higher order level to get to steady state, where each transition is an ideal switch with a loss associated with it.
Yeah.
You can't simulate overshoots and so forth, but you can get to steady state and look at things like efficiency and junction temperatures in the steady state environment. So that's very powerful. The tool simulation environments working together is kind of what people want to use.
Yeah. So quick simulation, so customer can have like an idea of losses in real time.
Within a few seconds to a minute, you have the result, whereas something in SPICE may have taken several hours.
So in a power supply, we have switching losses, conduction losses. How the simulator can work with all these losses? I mean, you can optimize for soft switching, hard switching, perhaps?
Yes, so we have, the PLECS models contain both loss types, so switching loss types, energy E-on and E-off, and conduction loss, along with a thermal description, a Cower or Foster network to capture the thermal impedance of the system. We do have models that are accurate for hard and soft switching, which we differentiate, and really this is an industry first approach that we're doing there. We take into account all these things. And one of the things that we do that's unique is the losses, whether it's conduction or switching, they are subject to the manufacturing distribution in the fab. So if we ship an RDS-on part of 18 milliohms, we're going to send 14 to 22 milliohms to our customers. And it's incorrect to assume you have 22 milliohms and a very high switching loss. The physics in the fab make those things change differently. And so the PLECS models that we generate take into account this negative correlation and let our customers design to the real loss, the real worst case, not some unicorn that doesn't exist.
Okay. And do the customer need to start from the scratch, or you have some predefined topology that can they pick up and simulate?
So for the generator, the model generator, we have a hard switching case and a soft switching case. What we're doing in this self-service PLECS model generator that's really unique is we're enabling our customers to come in and create PLECS models that are custom to their environment. And there's a big mistake that people are doing in the industry, and that is they're taking PLECS models that are based on data sheets. And those data sheets are based on measurements in some lab, like this double pulse tester there, or our competitors have labs around the world. And the losses that you get from those data sheets are not just influenced by the device, they're influenced by the parasitic environment. And so unless a customer has the exact same parasitic environment as some lab somewhere around the world, there's an automatic error introduced. And so the self-service PLECS model generator lets the customer come in and tune their parasitics to their application and get a PLECS model combined with our device with the right losses. I kind of liken it to going to get a brand new suit. And you go into the store, you pick your suit off the shelf, and it doesn't fit, it's too baggy or so forth. So you have a tailor in the store who fits it just perfectly to you. You come back in a week, and in this case a few minutes, and you have a perfectly tailored device. So that's the idea of the self-service generator.
And this is available for customer from your website? They can use
it's free of use. We just have a MyOn account that you register. It's free.
Thank you very much, James.
You're welcome.
To talk to you.
You too.